So problem 15 actually is it seems intimidating, but yeah, it's easy. So yeah, problem 15 of the MIT integration big confined exam 2017, which is a limit as n tends to infinity of the integral in, where I1 is the integral or from x equals to 0 to x equals to 1 of 1 over 1 plus square root of x. And I of 2 is the integral from x equals 0 to x equals to 1 of 1 over 1 plus 1 over 1 plus square root of x. As we can see, the integrand keeps nesting each other as you go higher and higher. And it's actually a very simple problem, but yeah, let's see how we may be able to solve it. So we're being asked to find the limit as n tends to infinity of this integral in, right? Such that I1 is the integral from x equals to 0 to x equals to 1 of 1 over square root of x. And I2 is equals to 1 over 1 plus 1 over 1 plus square root of x. And I'm assuming I3 would be equal to 1 plus 1 over 1 plus 1 over 1 plus square root of x. So I guess what we have, if our integrand I1 is 1 over 1 plus square root of x, I2 is equals to 1 over 1 plus I1. I3 is 1 plus 1 over I2, such that In, sorry, let's use a small n, right? So those are our integrands. And so when In or when n tends to infinity, let's say limit as n tends to infinity, what this means is we have the same integral right? And so what that means is that y, if y is equals to 1 plus 1 over 1 plus 1 over 1 plus 1 over, 1 over plus all the way, what that means is that y is equals to 1 over 1 plus y. And that becomes y plus y squared is equals to 1. And so y squared plus y minus 1 equals to 0. And we can use the quadratic formula, but we have to be cognizant of the fact that y is a positive. So y is equals to negative 1 plus b squared is supposed to be y, 1 minus 4ac, so which is 4 over 2, which is equals to negative 1 plus the square root of 5 over 2. So y is actually a constant, and that means that our integral as limit of n tends to infinity of in 0 to 1 being equal to that which is equals to square root of minus 1 over 2 dx, which is square root of 5 minus 1 over 2, 0, 1 dx, over 2x 0, 1, which is, so limit as n tends to infinity of in is that, and that is our answer. So yeah, ladies and gentlemen, thank you for your attention. I hope you learned something, but until next time, bye bye.